Thanks for joining us. My name is Konstantin, and I will be moderating today's technical session. We are here to talk about AI hallucination and different architectural approaches to handling them. Unfortunately, Michał Partyka, our CTO, had an urgent matter and couldn't join us live. But he recorded a video comparing different AI agent architectures to give you theoretical introduction into the technology and what's possible today. And after Michał's video, Tomek will show you how these architectures work in real life, in practice, and answer the technical questions that I have prepared for him today that come up in almost, actually Tomek doesn't know the exact questions yet because I've gathered them and modified them a little. And these questions come up in almost every technical evaluation. So let's start with Michał Partyka's pre-recorded video. I will play it right now.
LLM hallucinations and how we did architecture. Hi everyone.
Please let me know in the comments that you can hear
LLM hallucinations and how we did architectural products to work around them, to avoid them if possible, or maybe not possible. You will see that in action. That's going to be shown to you by Tomek Cieciuk, our sales consultant, who will dive deep into our product and show you how we avoid the hallucinations. And my name is Michał Partyka, and I'm CTO here at Zowie, and I'm very sorry that I am not able to join you on the live event. But because of that, I decided to record you this video to walk you through our architecture and my take on these hallucinations. However, let's start from a brief introduction to Zowie. We are in customer AI space for 7 years now. And that means that we are in this space even before the generative era came. And that is one of the reasons why we built a product that's really focused so much on accuracy and really, being able to make fully deterministic decisions, yet having a very natural AI agents interface. Why? Because we worked with a lot of enterprises that wanted to adopt this new era. However, they didn't want to lose the control when they need the full control. And that's how we ended up with the architecture that I will be showing you in a second. That's why this is important. So whenever a team wants to build AI agents, they are approached by the CEO or chief product officer or whoever product manager that wants to build AI agents that will converse with their customers. They usually ask questions like these, like what LLMs will I use? What technologies do I select? Do I use it in Python and I have a lot of different libraries to go, or do I use the technologies that I have in my products? How am I going to deploy? If it's Python, it's easier, right? How am I going to deploy it? How am I going to test it? Who will approve it from the security perspective? There's like so many different questions that teams are asking, and I don't want to disregard them. They are important decisions, but there's something that is even like more important, because it's on a more high level and an abstract way. You need to decide on the architecture of your AI agents. And usually what teams are doing, they're going with this out of the box reasoning with function calling. You just implement it yourself, use one of the Python libraries, or use the like newest SDKs from the big players that give you the LLM, and you end up with something like this. And I'm not saying this is a wrong direction, but I want to show you a risk that actually can be seen here on this slide. and let me walk you through this risk. Usually when you do reasoning, you ask LLM to generate a thought and select a tool that it would select in such case, and then you in the background execute the tool. So for example, this tool can be order cancellation action. If AI decides to select such order cancellation, you go and do HTTP call to your API and cancel the order. That's an example. And in this example, and it's very simplified prompt, I know it's very simplified. It's not showing like the full, really, reasoning approach or React approach or whatever. But I wanted to simplify and show you this very important example. So let me read this prompt. You have access to actions to pull additional information to communicate and answer questions. You must return only one thought and action in response. There might be more, like the personality, tone of voice, etc. But what is important, LLM here, and this was live tested, not with the newest models, but this was live tested. Action can be the following types. 1. Package status. Check order status for the customer. 2. Follow-up questions. Asks follow-up question to the user for additional required information. This is very simplified. Usually you have sometimes people have dozens of those tools. Sometimes they have even more. Sometimes they have 5. 2 is a very, very limited number of tools because such agent is very limited in what it can do. And the question from the customer is, what is the status of my package? So what would you think the LLM should choose? LLM probably in such case should choose the package status, right? It have only 2 actions, follow-up question and package status. Package status, check order status for the customer. Question, what is the status of my package? It's really straightforward. They just choose the package status, and what it does? To check the status of your package, I need more information. I do not have an order number, tracking number, or other identifying information. So the action that I will choose is follow-up questions. What is your order number or tracking number? What the heck, right? Why have you chose this? And really, this is a very simplified example. It was live tested with LLMs. Probably the newest models will actually work with this simplified task. But this is to illustrate you the risks around giving the power to execute actions to LLMs. And what happened here? LLM was trained with so many conversations from support when someone was asking about the status of the package, and probably human being asking about the tracking number or order number or things like that it even didn't consider to choose the package status. But wait, how LLM can consider something, right? LLMs are not reasoning. LLMs are producing the most probable next token that's in their dataset. So if we are giving them a very structured approach to, hey, package status, follow-up question, etc., what is the most probable next token? That might be this, and that's the exact reason for the hallucinations. And I know new models, new things, it's getting better and better, but you will never avoid this type of situations, especially when you put dozens of tools into your LLM. So we ask this question: can you trust the agent to perform actions? And we say yes, 100%. But you need to avoid the decision making to make these actions from the actual conversation interface. LLMs are amazing at conversing. LLMs are amazing at the natural language, so you use them for it. But make sure that you can make the decisions and that you can validate actions from your AI agent. So we decided to build our own architecture that I will show you in a second. That's the architecture. So, okay, the end of the presentation. Now we move forward to Tomek. Okay, I'm kidding, of course. Let's start from the center of this picture, the reasoning engine. This is the standard reasoning loop that you've learned about already, probably, and that that I've shown you that is prone to make errors, to choose wrong tools, but is amazing at driving the conversation with the user. So we have it. We do have it. And however, the tools that the AI agent can have there are no like actions, real actions that AI would be able to do, like order cancellation. There's only let's transfer this to the agent. Let's maybe hang up the conversation. Let's decide that it was irrelevant question because our AI agent has its personality and LLM can make this decision if prompted properly. It can do an answer to the customer. It can trigger cannot help tool, and inside of our product you can decide how to work with it. It can go to the knowledge base. The knowledge base is just the standard RAG approach. So you have articles, knowledge base articles. It will go search these articles and maybe it will have an answer. So it will like loop with these tools and finally, either answer to the customer or will transfer to the agent. We are orchestrating it so it some of the terminating actions actually happen. But what on top of that, right? We said we are not just FAQ. We want to make actions. We want to make real work for customers of our customers. So whenever the message comes, we have a system that is called intent router that is producing the tool candidates. So in the example that someone is asking about to cancel an order, reasoning engine will have, for example, order status and order cancellation tools for its disposal. However, these tools will never be HTTP actions that cancel the order. They will always be either our decision engine flow or our procedures engine playbook. Now, what are decision engine flows? Tomek will show you this, but this is our deterministic way to describe processes. And in parallel, actually using the full power of generative intelligence to drive these processes. There are agents hidden underneath, like data collection, that you decide declaratively how you want to collect the data, what data you want to collect. And our agent is able to actually collect this data loop and make sure that your customer knows where to check such informations, where to find this. It can converse and make sure that customer is able to share all of the data that is required to complete such process. Then usually a decision step comes into play. This very often can be a code block or API call, so that you need to check, for example, is this customer eligible for cancellation? And it can be eligible, maybe he or she is not eligible, and then you decide to return an observation, hey, this customer is not eligible for the order cancellation. So by going through this whole flow, instead of giving this power to the reasoning engine to make the cancellation, you're actually prescribing the process of how this should be made, and AI agent is executing this process. Our procedure engine is essentially the same. However, it's not deterministic flow. It's a natural language playbook, so you can write this playbook in the natural language, and LLM is looping over it and executing it. In this talk, in this webinar, we want to focus on avoiding hallucinations, so we'll be probably not showing you much of these playbooks because they are very prone to hallucinations. That's the system to do a quick POC or implement processes that you want to implement fast, but you are fine with certain level of not accurate conversations. You choose decision engine if you really want to avoid hallucinating the decision making. Agent can still hallucinate. No one can achieve full breakthrough in hallucination. Agent can do a hang up when they shouldn't do. Agent can select the irrelevant questions when they shouldn't do so. However, what we are trying to achieve here, is there a decision? Is this customer actually eligible or not? That's not a agent's call to make. It's not in natural language. It's in our proprietary decision engine system to actually implement this. Okay, that's it from the theory. I hope Tomek will make up for my absence on this webinar, and together with Konstantin will show you how you really can drive the decisions and avoid hallucination of the large language model. I hope this presentation was helpful, and enjoy the rest of the webinar today. Over to you guys, Tomek and Konstantin. And thanks everyone for listening.
Great. I'm sending my appreciation to Michał for the amazing video and the presentation.
Yeah, great intro.
Now, letting LLMs make decisions directly creates risk, and how separating conversations from deterministic logic changes what's possible today. Now, let's see how this works in practice with Tomek. I have prepared some questions based on common technical concerns and questions that come up in almost every technical evaluation when you're choosing which system to implement. And Tomek will try to address them, and we'll probably be able to even show you some live demos. Tomek doesn't have a prepared, pre-recorded or stage demo, so it will be freestyle, so it's authentic and real. So if Tomek, you're ready, I can shoot you the first question.
I'm ready. So all the data on my environment is a mock-up. There's really not much there. There's no knowledge. There's no routing, no procedures. So we'll be starting fresh and see how the question goes and what needs to be created to answer them.
Okay. So the first question that comes up pretty often is, should the AI agent pull knowledge from general AI knowledge like ChatGPT does or some other LLMs, or should it be limited only to a specific documentations, and why?
Interesting one. Actually, it happens quite often that the customer says, okay, we don't want, and 99% of the enterprise customers that have defined business processes and want to achieve particular thing with the AI agent say that they don't want the agent to access external or internal, let's say, LLM knowledge that it has and was trained on in any sort. But we have some, let's say, specific use cases where it might be beneficial for the customer, but it's always tricky because once you give this small window for LLM, you want to use just a part of its knowledge, I haven't seen implementation that worked that way, that you only take just small part and all the other things you want to control. The LLMs are amazing in in jumping across the fence if they can. So giving this possibility is risky. It's risky. And how we approach it on the Zowie platform. So this environment, as I said, is empty. I don't even have persona. I don't have anything here. And I can just let me go with the first question that comes to my mind. Who is Zowie? Obviously, it doesn't have this information. I mean, probably it was trained with the data that used that information. But as Michał was showing on this big graph, so the middle part was this green bubble called reasoning engine. So right now, whenever I ask any question, it goes to this reasoning engine, and it has this set of tools like search the knowledge base, irrelevant question, cannot answer. So in this way, it probably tried to search knowledge base. It was empty, so it just returned, sorry, couldn't find the information. So yeah, in Zowie, we explicitly limit the knowledge to just what is provided.
And it's, I understand why. So, and you recommend this approach, I understand.
I recommend this approach. It really depends on what the company wants to achieve, because I can see some scenarios, maybe internal ones are easier, as we in Zowie focus mostly on customer-facing agents. But for internal scenarios, when you can afford to have hallucinations, then probably it could work. It could work in some cases.
Okay, you showed that this environment is empty, and if it had like some knowledge base and stuff, what happens if it doesn't have the exact knowledge to answer the question correctly? Does it always say, "I'm sorry, I don't have enough information," or can it do something else? Yeah.
So what happens when it doesn't have the knowledge? Like how do you know that? Let me create a simple article. So I'm adding the knowledge base. Obviously, I have tons of ways, so like creating data pipeline over API, but this way I will be using manual process because it's the quickest for me. We don't have like 1 hour to create such. So I created a simple article which I'll call Zowie offering, and I included actually the answer to my question. So now I can ask, what is Zowie? Hopefully it will find the article. It should. So it answered based on the knowledge article. And you've asked, can you repeat the question, please? What it does, what happens when it doesn't know the answer, like in the backend? So actually in the supervisor, we can go through all the conversations. And so let's go for the first one. So I said, hi, I'm your AI assistant. I asked who is Zowie. He didn't answer it. And actually, we have something called moments. So moments is like a predefined set of processes that are present on every AI agent. In this case, this is customer greeting, training gap, and request for transfer. So customer greeting, this is pretty simple. First message that is sent to the customer when it interacts, right? But what happened in our case, and we can see it on the right side, processes, it called customer greeting, but after my question, it went to training gap. So it went to the process that is called every time it doesn't find the answer or doesn't know how to answer the user question based on the tools that it had available in the reasoning engine. So it goes, basically, this is one of the tools, like it cannot answer. And here in the training gap process, we'll probably cover processes later on with some other questions, I believe. I hope so. But this is what happened. This is how we know that this conversation, this interaction actually couldn't be resolved fully. Like at least one user question couldn't be answered.
Okay.
So yeah, we can flag all of them.
Okay, I see that we have some questions in the chat. We will address them later after my set of questions, which are prioritized.
I don't have chat open, so if there's anything related, let me know. But again,
a Q&A session and we'll address all the questions. If some questions are very technical or product specific, Michał actually will address the questions. I will save them and post them on LinkedIn, or we will send an email with the answers to you directly. So don't worry, all the questions will be addressed. Okay, thank you Tomek for answering the second question. The third one is actually connected to what you already showed. And Michał showed the green bubble, the reasoning engine, decides decides what to do next, which process to call or action to take. And my question is, how can I trace what happened actually with the question, with the specific request or question?
Okay. So going back to the interaction view, we have, let's say, two modes. One is the simple mode, when we see just the transcript, but we have this developer switch button, like the magic button that turns it into the fully fledged log. And we don't hide anything, actually. You can dig down up to a single LLM call. So quickly going through what happened. So we got this welcome message, then we have who is Zowie question, and we see in the middle, I don't know if it's too small, maybe not, reasoning started. So we started the reasoning loop, the green bubble in the middle. And we can actually see everything that happened underneath. So it's not like a black box, like we can track exactly what happened. And so let's say we try to see what it did first. So it went through reasoning step. Reasoning result was customer is asking who is Zowie. This is a direct question about a specific entity. I will use the knowledge search tool to find information. So that's what I assume it would do. Then we have initial search. Basically there weren't any information on that. No sources selected. What happened next? And there's like the proprietary LLM calls that our product team worked on to basically make this reasoning engine work. And the final thought was I have attempted 2 knowledge searches for Zowie, and basically it didn't find anything, so it went with cannot help action. And this is also important, like cannot help action doesn't seem like a particularly useful action to have, but with LLMs and the hallucination, it's always good to give them alternatives, because when you design the process and something in the process breaks, and the LLM doesn't know the next step, like it doesn't have clearly defined what should happen next, then it's very likely it will invent something. But in this case, we have this training gap, we have transfer to agent, we have cannot help action. There's always something to choose from. So that's also very important in limiting the hallucination. So yeah, in this view, you have full visibility on what happened underneath.
Okay, seems great. Okay, the next question is also very, very popular. Many companies would like to integrate their CRM system with an AI agent, and the question is, how should you handle the security side? Because like to prevent unauthorized data access, because I understand that like if you can't trust that the AI agent takes only controlled actions, it can send the data somewhere where it shouldn't. How should you handle this?
So securing API access, basically accessing the CRM is like the low-level thing you should do when you implement the business process that should actually help human agents in offloading them with the simple processes. Like CRM API calls are the basis for a lot of things, even order cancel. So there are two ways to approach this. And I think order cancel was also the process that Michał was talking about. And he was talking about it in mentioning the procedures. So I will show two ways how to achieve that. And I will explain what is the problem with the first one compared to the more deterministic approach. So let's say we have LLM, we're just starting. We want to create a procedure that would handle order cancellation. So what would be the tool? The tool would be like order cancel. Cancels the user order. I will not play with JavaScript. I will just need tools like a mockup, and let's say I need fetch order. Fetch is an order. So I created two potential API calls to CRM that our agent could use. And then I could create a procedure around that. I will say order cancel. And we can define step-by-step instructions. So your role is to help you his order. And then we say first you need to ask for order number. With order number, call fetch order. Check if the order can be returned. And then if yes, then call order cancel. So usually the first versions, or there are still people making AI agents like that, but there are a couple of problems with it, right? Whenever we have if or check if, we're counting on LLM to make the right logic decision. Something, and as we know, it's not going to be 100% accurate in that form when we're leaving such decision to LLM. Asante, could you mute yourself? I think there's background noise catching a bit.
Okay.
Yeah, much better. Thanks. So there are two problems with that. We're counting on LLM to make the logic decision for us. It's not going to make it 100% accurate all the time. So we're risking that, for example, we're going to cancel the order that cannot be returned, or we at least we're going to try, or our agent will try, or we can actually at step here ask user to confirm if he wants to cancel the order. Yeah, so there's this user confirmation step. Obviously, this can be skipped as well. So in general, it's a recipe for disaster. Trying to make a deterministic logic in processes. Not to mention what happens if we add more, like if, because during testing, more ifs will come. I can assure you that. So what's the alternative? Alternative could be our processes. And Michał mentioned this is like 100% accurate from the business perspective, that we can design a process here that will make correct decision each time. Why? Because the logic won't be delegated to LLM. Actually, we'll handle that deterministically, and we're gonna use LLM just for example, collect data. What did we need? Order number. Order number. User provided order. Let me quickly drop the process here. So we'll be using what the LLMs are best at. So handling the conversation with the customer and extracting information that we need. So order number, guidance. Actually, this is LLM. I can do that in a natural language like ask customer for order number. And so we have the first step. Next step would be fetching the order based on the order number. So we have a script block where you can basically do any JavaScript logic that you need. So in this place, I would normally call API to fetch order and check if it's eligible for return. And I can skip that far. I don't have API like that.
Someone asked if you could just zoom in a little.
Yeah, sure.
Bigger.
Sure. So basically here, I will not do any integration. I will just write that eligible is true for return. And that's pretty much it, what I would need from the script. So let's name it like fetch order, check for eligibility to return. Make some mistake, but it's fine.
Can you zoom in the whole
Yeah, I'm doing that.
Okay.
So what we did first, we collected data, then we trying to do some API calls to check if it's eligible for return. Let me just create another variable for return, and that I'm gonna use for the decision block. So usually in the procedures, you remember that we put if the order is eligible, then call order cancel. Here, we're not letting that. We're basically using script and decision blocks to do that instead. So I can go with is eligible, yes. If can be returned. I will just go with the happy path. It's going to be quicker. Then we can use the options block to ask user if he wants to turn the order. And we're going to give yes, no, answer user order, and the second one user. And then basically we just need two scripts, actually one script. This is going to be order cancel, not going to enter anything here. And after order is canceled, then basically can say confirm that the order. And that's it. And it took a bit longer to create, but this way we have full control of the process because of the script blocks, because of the decision blocks. We have full control when and how we call APIs, how the logic works, and we're not delegating that to the LLM. So yeah, this way, this architectural approach is much, much safer. Basically, procedures, whenever we need anything close to 100% accurate business logic, won't do. We need something like processes.
Okay, thank you. The next question is how scalable this architecture is comparing to standard traditional RAG and prompt based approach, like with procedures.
Yeah. So when it comes to scalability, and one process doesn't affect the other, unlike the procedure. So I can go with the next steps, like ask customers something else, maybe call some other systems whenever I need, maybe add more decision blocks like this, split it into more conditions, like no, maybe, etc. but it doesn't increase the risk of hallucination. So the complexity of the process can grow, but it will affect it locally. Like, meaning, if I make some mistakes here, this process will not work, but if it will not affect any other processes. When we go to procedures, however, I didn't say that procedure, but if we go with 1, 2, 3 steps and we keep adding them, let's say we have step 10, we have step 15, and then I need to add more. With each step, the increase of probability of hallucination grows basically non-linear, exponential. And if I have all the previous steps and I add another, if the customer says something, does something, or the API returns this and that, it can affect all the previous steps that I had. So scaling process increases complexity, scaling procedures and adding more, let's say, tokens to the instruction increases the risk of hallucination.
Okay.
I hope that makes sense. That was good.
That makes sense. So, like, Michał also mentioned that it loops the same prompt every time. It affects like all the. Okay, yeah, it does make sense.
Because when we do a procedure, like ask customer for a name and then ask customer for an order number, then what it does, it receives the same prompt each time. It has to figure out at which step it is based on the conversation history. That's usually how it works. So that's problematic because with step 10, like say, call fetch order tool, it should know that it's at step 10. But can it skip some steps on the way? Of course.
Okay. Great, thank you. I will ask only one more question, and then we'll move to Q&A section 2 to be able to answer more, because I see that there are some in chat. So the last question will be, I know that some companies ask if they already built an agent in-house, like, is it possible to integrate it with a system to build more agent and maybe orchestrate them, and how would this work?
So companies that are already developing their own AI agents, that's what you mean?
Yes.
Actually, yes. So on the first part of the presentation, if you remember that, we said that the Zowie is actually customer AI agent platform, and that platform part is something that we focus, like foreseeing the future, that basically all the departments in an enterprise might be building their own agent for their own purposes. That's why we are trying to keep the possibilities open with external agent block. Meaning, it can be integrated into processes. For example, I might have a team that made super great logic how the order should be treated, if it's possible for it to be returned or not. So I want to reuse that logic, right? I don't want to recreate that on the Zowie platform, although I could. So let's say the external agent would handle that part for me. And we need to integrate with that. We can pass all the previous conversation history. We can pass persona, all additional things that it needs to perform the work on his own, what it was built for. And then it will basically handle the part of conversation with the customer or part of the logic. And usually it's like a conversation with customer on the particular topic that it does. For example, we could build like a loan negotiation agent that is done externally, that is connected to all internal systems, and we don't need to recreate that on Zowie end. And actually, when you Google like Zowie external agent SDK, let's see if I'm able to find that. We have full documentation on that. And let's go with Python 1. That actually explains how to connect it, how it works, what functions it has. And it can work alongside all the agents that are present on Zowie platform, meaning it will also be visible in supervisor, like everything that was done on the external agent side. So we have, let's say, one place of truth for all of that, and for auditability as well. Some internet issues. Okay, hope that covers the question.
Yes, and that's actually great, and especially since it's integrated into processes, which is deterministic, as we've learned today. So sounds good. Okay, so I think we have 12 more minutes to answer Q&A session. Can you please disable the screen and open the chat so you can see the questions?
Sure. Wow, 30 messages. Wait, I will need to scroll at the top.
You can also click show near the question. If maybe you couldn't. Okay, I can. So you can just read the question. I will show it on the screen so everyone is able to see it.
I have no idea how to do that.
You don't have to. Just read the question. Let's start from the beginning.
Starting from the beginning, could you let us know the order? Decision engine first checks knowledge base articles or intents router, if there is both available for the question. Actually, we could test that, but I haven't created the routing for the process. So to give you like a quick explanation, it checks for both. And if we have both article and intent that should route to a process, then we have something that's called disambiguation process that actually will ask user additional question, because I can say something like, I want to cancel my order, and is that an intent that I actually want to cancel my order, or I just want to know how to cancel my order? So maybe that's a bad example, but those kinds of situations can happen usually. And in that case, when there are a couple of options, whether to go to decision engine or use knowledge base article, the agent will ask, going through that disambiguity process, what did you mean? Do you mean you want to cancel the order, or just to know the general rules how to cancel the order? Okay, I hope that answers Nazar's question. How do you evade latency with many tools? Actually, on our end, in the reasoning engine, it's not that many tools, and going through all of them, it depends on what's called. Like if you have 200 knowledge base articles, then you need to narrow down the search. There are a couple of ways to do that. Probably don't have time to show how we do that, but the number of tools that we use for now by default in the reasoning engine are not something to give concerns about latency. There are much more other impactful things that can affect latency, but the number of tools, at least in our case, is not something that is worrying us now. Shouldn't you provide the Zowie offering services in personality instead of knowledge base? So personality in my example was pretty much empty, but maybe it's a good way to go through that. So what we usually do, we just give a name, we just give some business context, your service customer support expert, something like this, tone of voice, be emphatic. the problem with including here the knowledge instead of the knowledge base is that the personality is passed in the system prompt in almost every LLM call. So in most cases, the knowledge that should be sitting in the knowledge base won't be applicable to the particular process. Let's say I'm providing an answer or extracting information in collect data block, and I'm passing persona to forward the message. If I included here all the knowledge, basically it would like wash down the actual business context it has and the actual tone of voice it has. So there are very few exceptions where actually including information in persona can be helpful, and those are mostly to overcome technical limitations, but I would just go with RAG in that case. It's much cleaner that way, because washing down persona can have very detrimental consequences, especially when you write something like be a helpful agent. This is like a gateway for it to hallucinate. So I would be very careful with persona. Okay, now I lost the track of the questions. Latency, that one, personality. Is insights on the left sidebar a new feature? It is actually. It is. Currently, it's in beta, so probably not everyone is going to have access to that. But what this does, basically, you can ask business-related question, and it goes through the whole interaction history that the agent had with the customers and creates a report. So let's say, what are typical issues with our luggage wheels? Stuck or sticky. So basically, it's data mining using LLM, because customers with interactions with AI agents share a lot of information. What are the reasons they're not happy and such. So actually, what enterprises typically do, they get all that transcript, move them to their internal database, and then they do BI activities on that. But actually, we found a way to keep that on our platform, to have the value-added service for our customers. And by simply asking a question related to your business, you can get answer, you can get graphs, even raw data that was considered for the answer. So yeah, this is the new feature. It's still under development. It's currently in beta, but probably coming soon. And Michał is not here, so I can make promises. No one to correct me. Okay. I got lost again. Okay, Zowie engine sometimes does 3 reasoning steps, sometimes 2, and sometimes only 1. How to understand this? Could you please explain? Zowie engine, that's probably inside the process. So I would have to set a routing. Yeah, because Zowie engine is something that we call internally. For our process, let me quickly create intent so agent knows what to use for order cancel. Good. I think I didn't give a name to it. If it wants to cancel order, and we need to add a couple phrases. Want to cancel my order. Don't have misconception of the old NLP approach where you needed like 200 examples for it to correctly choose intent and recognize it. This is, I will just need a couple of examples for it to be able to recognize the intent. But yeah, in the older chatbot structures, you needed like 200 samples. to get it ready. Okay, let me activate this. Let me just quickly check if this was new process. Yeah, so I can now say I want to cancel my order. So my order, because we want to answer the question, why did so many LLM calls? But I don't know why my supervisor is not loading. We might have some issue on the test environment. So I would actually need to check. But to give you an overview, first, it checks whether the customer already provided the needed information, meaning if I'm asking for order number, but I say something like, I want to cancel my order 123. So I already gave my order number, so it doesn't have to ask me for the one, right? So now it just asks me if I want to return the order. So this is the first one, whether I already provided the needed information. The second LLM call would be if the user requested to be transferred to an agent. That's the default one. And the third one would be to actually create an answer or ask the question. So we split those three. They're done like in parallel. So we have better flow of the conversation. And we don't ask customers what he already provided. So yeah, there might be a couple. Why those are split? To have better accuracy, of course. Yeah, I think I lost my authentication token. I would need to log in back to get my supervisor. But anyways, let's go with the next ones. Constantine, you're muted if you're saying something. I don't know. I think we're out of time.
Yes,
So,
we are, but you can select maybe one or two more questions, and the rest will be
cherry pick. Okay.
answered via email.
So the very next one, could we assume that moments are somehow mirroring the skills for agents, where we define where should this action be taken by an agent within a workflow? That's a good analogy. So those are just to show back what we meant by moments. Those are actually, let's say, skills and tools that in the reasoning loop, the AI agent can look. So actually referring to them as skills is a good analogy. However, you won't be able to define when those are called, only what they do. And when they are called, this is like proprietary technology of our product team, and they're working hard for us to recognize when there is a training gap, when there is a request for transfer. So we'll handle that part, and you can define what camera disconnected. Okay. And you can define what happens when those tools are called. But yeah, those are more or less like skills. Hey, Constante, can you hear me still and see me?
I can see and hear you.
Okay.
We still have people here, so I think you can answer one more question.
Because I got just a notice that my camera disconnected and I need to restart the studio.
Please don't. Please don't.
Okay, then basically I have no control. I have control of my screen. I think you still can see it, but I cannot view chat.
Okay. So maybe I will read one more question to you.
Sure.
The more LLM blocks there are, the less deterministic the response might be. Is this correct?
The more LLM blocks, the less deterministic. If we mean by those blocks, then no. If we mean by blocks, like in procedures, I didn't save it again, like blocks in terms of here or tools, then yes.
Okay.
I don't know which blocks we refer to. But in the process, each block is not like we're out of all of them, we're creating one prompt. No, like collect data will have its own set of prompts. Script doesn't need any LLM calls. We can of course call LLM from inside the script, but that's another story. Decision, no LLM calls. Options, yeah, there are a couple, but those are simple. Basically getting yes, no answer from the customer. Again, script block, no LLM call, and message block. This is like very, very basic LLM call that basically ask LLM to form a message to the user. So adding more of them, like if I add more message blocks or other blocks, those are separate ones and will go as separate LLM call, meaning the previous ones don't affect it. Obviously, the agent will have the context because of the conversation history, but what I did in the first step, that's, let's say, of a backend and how many calls there were, will not affect the next ones. So no, in this case, it won't decrease the accuracy.
Okay. The last question, I think it's very relevant
Mhm.
to the session. How are you, if you are, tracking accuracy of LLM's decisions?
Oh man, this is like a whole topic for another discussion. But yeah, it's a tough one. Obviously, we have a set of even the dashboards that I'm showing right now. Like you can go exactly into processes and see which one performs well and which one resulted in transfer to agent. So you can view which on which maybe you should work a bit more and which one performs well. And we also provide you with technical account managers usually, so they dive deeper into all the data that we have from the agent conversations. But that would be like my first step. When I see big transfer rate in some knowledge-based article, in some process, whether in some intent, that's the place to look for. And then what other steps you can take? There are many. So it's best to take the discussion like out of this call if you don't have time.
Okay, thank you very much, Tomek. Thank you very much for joining and
Pleasure.
the demos freestyle style. And thank you to Michał for the recording, and thank you very much to all of you for joining us today. And we will see the recording. We will send you the recording and the Michał's presentation, and address the rest of the questions later on.
Okay. Thank you. Have a great evening.
Bye bye.
I guess.